So we are about to start. Hi guys, happy to have you all here. First of all, thank you for accepting our invitation and spending your lunch break with us. Seeing so many registrations means a lot to us. It tells us we are not alone in believing that as AI changes how we write code, engineering principles matter more than ever. Let's start with a quick introduction to us. I'm Halina. Hi, I'm a technical lead. Oli is a software architect, and we are both technical trainers with over a decade of experience. We are helping teams build maintainable software. And our passion topics, as many of you may know, is domain design, software architecture, clean code, and of course, helping teams apply those principles in practice. And as a thank you for you being here, we have prepared a few gifts for you, so make sure to stay until the end of the session. And you will also get access to a sample codebase we will experiment on in this session, and you can try out the prompts on the code we give you later after the session. Also, feel free to post your questions in the chat throughout the session. We will answer as many as we can live, and if we don't get to your specific question, we are always happy to chat after the session. So, Oliver, stage is yours.
Thank you, Alina. So hi from me as well. I hope you can hear me well. If you don't, then write in the chat and I will try to adjust it. And so let's dive into the topic. So probably you have noticed it's all about code. It's about how to keep it clean. And also that actually, when you look at LinkedIn and everywhere around, it seems like all those practices that we used to spend years on refining, like clean code, software craftsmanship, all these kind of ways of implementing software, they seem to have become obsolete in the age of AI. But is it actually obsolete? This is a question we actually want to look at here in this session. Very briefly, of course, we don't have that much time, but let's just start. And we start right away with a small change or something that you might find familiar when you have a requirement or a user story or something, and you actually need to implement a change. And the change here is from a code base we use in some of our workshops. It's about when you, for example, go to a gym, then you typically have some kind of subscription you can subscribe. So you can subscribe to a gym for a membership, for example, for a year, for 2 years, whatsoever. And our example will be exactly something like that. So you have, on the one hand, the one microservice that is the IAM system, so the identity system where you actually have the customer or you register the customer. And on the other hand, you have the actual fitness management system, which is another service that somehow needs to know about this customer. And the service manages it like that. If the customer is created in the identity, it will actually publish an event to Kafka. And the fitness management system will then consume this event and create its own little customer cache on its side. So it doesn't have to do synchronous calls, but it can actually do just rely on its own cached customer data to actually send out invoices, send out any notification that are required when you actually subscribe. So it's the basic flow you actually see down here. You have identity, you create a customer, then it's like customer registered will be sent to Kafka, and then the fitness management system will consume that. Now, that small change that we actually want to do is that the customer updates their email address. So first of all, we have registered it, but now we actually update the customer, because this little event or this update is not yet present in the system. So if you're interested and also want to try it out yourself, you can find this code base here in the CodeArtify repository. So we have the identity here, which will create the customer or register the customer and also update it if we implement it correctly. And then the fitness management system that is it's a Kotlin code base here. So it will actually have these different, let's call them contexts or bounded contexts there where you see the customer cache, and also other ways of managing memberships and notifying customers. So for the notifying of customers, especially when you have a new invoice, we actually need the email address. So the small change we want to do is we want to be able to update the email address. And let's just start right away with doing that using a single agent. So I will show that in, there are people that probably have used agents before. On the other hand, there are companies that are quite strict on using agents and chat. So probably not everyone has so much experience in using agents. So we chose an example that is somewhere in between, something that we have seen in lots of companies, namely that you have your chat in your IDE and you can actually interact with the code directly in the IDE. And this is actually what we are going to do right here. So what we are going to prompt the single AI agent is to read the README, inspect the relevant code, and then change when a customer updates their email address in identity. Future invoice notifications in the fitness management system should use this updated email. So implement the feature and run the test. This is the basic premise. And as you can see, we have the video here on YouTube for you to actually also be able to watch it again. So how does that look like? So we have here our chat, which is an agent. We just simply put it to full access so it doesn't stop at every step. And we use codecs in that example. It doesn't really matter. We just want you to show how it will create this little change, which is basically the email address should be propagated if it is changed. So we post this prompt. It's basically saying what I showed before. And we can see here that it will start actually by reading the README and map out how the identity should actually, or the identity and then the invoice notification path should actually interact with. So if we look at it, it sees that there are no tests yet for that example. I hope you can read it. If you don't, you can actually, I hope you can zoom a little bit in, because my zooming here is a little bit limited. But the important thing is it will actually start creating something quite reasonable. So it will see that the notification policy already fetches customer cache. So it has identified that it is actually some asynchronous call here that will create a customer cache on the other side in the fitness management system. And here we already can see that it is actually proposing a customer updated event. So it sees that we are updating the email, so it proposes us to have a customer updated event on as an integration event between the two systems. And it will continue doing that. And then let's go a bit further. I mean, it will do the test, which is great. We also asked it actually to do the test, so it does all these kind of things. And the important part then becomes when we actually look at the implementation. So if we look at the implementation here, we have here the customer service on the managing customer side, so on the identity side, and we see that it has created, additionally to the initial customer register that we have, so the creation of the customer, it has created a customer updated event. So we see here customer updated integration event version 1 with the ID, the name, the email, date of birth. It has added a test, which is great as well. And now we see also how this integration event actually looks like. So we see here all the fields are present from the customer register, basically. So we only have these 4 fields. Of course, in a real system, you would have many more fields probably, but it added all of them. This one would be on the managing customer side, and this one would actually be on the other side, on the customer cache side. So these two integration events are mirrored, of course, in the two systems. And here we have the consuming side, if you're familiar with Kafka-like listening. So you see here, customer register was the first thing, and the second one was the customer updated here, which basically just takes the data that comes from the event and puts it into this local cache. And it adds a test as well. So, and it even updates the README even better. So now we see here that it has actually created something very impressive. So it has actually seen the boundaries, it has created those two integration events, and it updated the cache. So it actually did a working or created a working system. This is very impressive. The question we have to ask ourselves now is this actually what we wanted? I mean, it's impressive, but does it also mean that it is settled? Just because the code runs and everything is green and it looks quite good, it does not prove that the design decision was actually right. Because what decision did we actually make? So we said just, well, or the agent proposed that we do a customer updated event. But what we actually only wanted was to update the email address. There was no actual requirement that said, well, let's update everything. Let's propagate everything to the other system. This was something that it just invented, and it also used a bit of this CRUD language. So the CRUD language creeps into requirements and stories quite often because business people are used to talking in CRUD language as well. So if you say customer updated, what does that actually mean? Wouldn't it be better if we just said something like customer profile updated? Because that's probably what happened. But again, we don't know if that is actually what the customer wanted or the business wanted, because we only said, well, we want the email address changed. So wouldn't a smaller event like customer email address change be better? So these are all things that we actually didn't tell the agent. The agent just inferred whatever it was seeing around in the code. So the design question become, for example, who owns the data? We have seen actually it very well found out from the README, from the code, that actually the identity service owns the data. The boundaries are crossed with these Kafka events, or at least with Kafka in between, and the integration events that go through Kafka. And the question then is, well, what should the agent actually copy? So if we look at, just for everybody to be on the same page, what is the AI coding agent actually working with? So typically an agent is not going to, or the LLM is not going to relearn everything based on your repository. Instead, you have a task, you give it to your agent, and the agent gathers some context, for example, the current file, maybe nearby files, maybe some open tabs. It will have some code-based modules. It has your README, which we actually saw before. If you look closely, it read the README. It has the tests and also the logs. It has previous messages you used in the same chat, basically. And then you have these additional files like AgentsMD, ClaudeMD, skills, goals, rules, all these kind of things that you actually give as a context to the agent. And from that, the LLM will derive some patterns, some next steps, some actions, and then the agent again will read the file and edit the file and maybe run some tests, and then the loop simply continues. So this is how it works in general as a big, or as a large overview here. So the problem here is that means that we cannot just say write clean code, because if we tell the agent to write clean code, it actually doesn't know what that should mean exactly. Clean according to what? Because if we actually look at the code, the agent may have seen customer registered as we have before. It saw that we have some Kafka consumer, some local customer cache maybe. It reads the README, and maybe we have written down some specific limitations like the update that it is not propagated, which is great. But if we don't write it down, well, then where should the agent actually know from that this is a current limitation and not a pattern to follow? Again, the tests and the nearby code, all these things, this is what the agent actually sees. But the team may have known that, well, this customer registered event is actually a very good example because it captures the business intent. So we register a customer. It's not like create customer, but we register him. And on the other hand, we have this current limitation. The update doesn't work yet because we didn't have time to implement it. Maybe we have some demo fallback REST API that we only use to actually add some data in case our database didn't work. But if we just put it there, the agent may see it and say, oh, in the next feature that I implement, I will actually also add this fallback, this way of adding data directly, but you actually don't want to have that in your productive system. Also, something that will happen a lot of time is that you have some legacy shortcuts, some stuff that somebody years ago implemented and nobody really actually knows anymore why it is there, but it's just there. But maybe the agent will just see that and think that might be a good pattern. On the other hand, you might have started migrating, and when you started migrating, you have a desired direction maybe, and you never tell the agent that this is actually where we want to go, and on the other hand, this is the direction we want to leave behind. And of course, any business meaning, what does that mean? These are all things that the team knows, but not necessarily the agent, especially if you didn't put it into the code. So the main core insight is the code base is your magic prompt. So when you try to actually ask the AI agent to create clean code, your code base needs to have the correct signals for the agent and the model to actually be able to derive what clean means. So you need to have good names, you need to have descriptive tests, packages. The events should be also named well. The README needs to show what is actually desired, what is not desired, and you should also name the workarounds in your code that it should not follow, or why it actually is there. And from all these signals, the agent will derive basically the context, or it becomes the context for the agent, which will then put into the model, which will derive patterns, and all the patterns that it sees from the code base become evidence. And only from that, the tool actions like edits and tests and commits will actually be derived. So the AI will always copy the evidence that it sees. It will not copy the intention behind it. So again, when the agent sees customer registered event, the team meant this is a good example for integration. On the other hand, if it sees customer cache consumer, that is like, well, we intended that as a local copy. And if you then have this no update propagation, well, if the team doesn't say this is a current limitation, it might be that we never can update that. So in future implementations, it will not think about updating it maybe. Or again, this backfill endpoint, if we don't specifically show that this is just for demo purposes, it's not a pattern to follow, then it might add it all the time if you're not careful. And if you get like 100 files to review, we all know what happens when you do it manually. Well, you will probably skip through part of the review and just say, well, if it works, that's fine with me. And this is exactly then a potential issue if you have these possibilities to actually add some data into your system that are not supposed to be there. So if people say, well, stuff like clean code is now obsolete with AI agents, in our opinion, we disagree a lot. it's on the contrary. Clean code matters much more, not less than before. Because before, bad code was harder to read for humans, okay, but humans are very well at adapting quickly and knowing also, okay, I implement it like that because that's my way of working. And for you, that might be okay, but for the AI that has no other context than your code, well, this just becomes much worse input for AI as well. So bad code doesn't only matter for humans, but also for AI. So what you actually want to achieve is that you have a clean enough code base. I mean, you don't need to follow every principle to the last extent and every pattern that you know. That might not be clean code. It needs to be clean enough code base that you actually have clear names, you have focus tests, you have visible boundaries like we have in this little example that we've shown, and you explicitly name also the trade-offs, things that had to be decided just because it didn't work in any other way. If you have a messy code base, and we know everyone probably has seen a messy code base in their life if they have worked with larger companies, especially, and older code bases, you always have this scatter meaning. You have rules that span multiple modules and other places that you cannot like pinpoint where it actually belongs. You have examples that are in one direction, and then you have examples that go in another direction. Sometimes, if the code base is very old, that can be because just at this time of the code base, it was actually how we developed software, and a little bit later, the software was developed differently. So you have examples that the AI will not know exactly which one to follow. And of course, anything where the knowledge is scattered or the knowledge is gone because the people that actually implemented it, they didn't write any documentation, any comment, and they just went away. Then you have some stale shortcut stuff that nobody actually remembers why it is in there. And you want to avoid that if you want to work with AI agents and create cleaner code. So the dangerous mistakes are really not the syntax mistakes. I remember last year when I was sometimes coding with Claude in a little bit messy code base, it would actually break the code sometimes. So it would not compile anymore. But with a little bit of iteration, it would then get it to run again. But this is not really the problem. The problem is really when you have wrong service boundaries, when you have when you don't really know which part belongs into which service, when you have aggregates and business rules that are maybe large God classes where you don't actually remember where to put which rule, or when the event name is wrong, when you have CRUD patterns, all these kind of things. If you have limitations in your architecture, these are all things that lead to a green build, but in the end you have hidden design debt. And when you have hidden design debt, that will accumulate over time, especially now that you have agents that work with your code. And we actually see now that it actually matters more than ever before. So we see that cleaner code is becoming AI readiness. So we have, for example, this research here, which you can also read then when you look at the slides. Where it says code for machines, not just humans, quantifying AI friendliness with code health metrics. And one of the results is that human-friendly code is more amenable for AI interventions, and the higher the code health, the more often AI refactoring preserves program semantics. So we see here that the better readable for humans the code, the better it is also for LLMs. And also the same conclusion has Timon Krebs in his blog article, which was published right a bit after we announced this session, which actually has a very similar name. The code base is the prompt. So we see here that everyone is arriving at the same conclusion. If your code is bad, it is bad input for your AI system as well. But how can we actually make it better? Well, again, it depends on the context. And the context that AI agent sees is important to make better decisions and create maybe also better solutions. So what we have here as an example of how you can do that, and you can also download that from our website, is so-called skills. So these are skill MD files that are actually used by your agent to make design decisions or to write code. So we have two skills here that we will show afterwards to implement the same feature again, just with a little bit curated instructions. So we have the architecture skills. This one is derived from our modern software architecture design patterns workshop, where you actually go from simple vertical slices to all up to clean architecture or domain-driven design, event-driven systems. But it will always decide the least complex version it needs to actually implement the feature. And on the other hand, we will use that for assessing where to put the change. And on the other hand, we have the low-level clean code skill from the clean code workshop that analyzes more of the code smells, refactorings that need to be applied, and how to implement the feature in the smallest safe way as clearly as possible. So we will see these two prompts. The first prompt will assess the architecture, use the modern application architecture skill, and before we implement it, it should analyze which services are involved, who owns customer contact data, sync calls or integration event, what event should exist, what is a good example, what is only a current limitation, and what is the smallest useful sequence. So it will not implement it using that, but it will analyze the code base to suggest a good enough solution. On the other hand, after that, we will do the first little implementation in the same chat using the clean code refactoring skill, where it basically will consume the event on the fitness management system side, and the other side will then be a known implementation where we update the email on the publishing side, and then it will publish it to Kafka. So let's have a look how that is going to look like. So you actually add these, or can add these skills, especially if you use something like Codex, you can have this .agents and then skills folder. And for each skill, you have an own folder here. They're all called skill MD, clean code, smells, refactoring, and modern application architecture in that case. And we will just basically post exactly that, that prompt here. It's going to be a little bit bigger because it also needs to know what we are actually going to do. So a customer can update the email address in the identity service. Future membership invoice notifications should use the updated email address. Let's see what it will actually do now. So it uses this skill as guidance, and it will also see here that it already published the customer registered. So let's see, let's scroll a bit through. Again, it sees notification path already uses fitness management system here. I have enough context to make the architecture call, grab line numbers and stuff. So using model, it treats it as an integration heavy, eventually consistent read model update, which is true, not a domain workflow. And the right design is customer updates email identity, identity persists the change, identity publishes an integration event, fitness management system consumes it, the update is local customer cache, and future invoice notification already read that, so it will work afterwards. And then it also makes a suggestion, and the recommended event type is customer email address change. So it actually improved on the design because it sees, well, what we actually need for this requirement is only the email. We don't need to add all the fields, just the customer updated like without the instructions. It actually tells us here that if we want to update the entire profile, maybe we can have a broader version, which is customer profile updated. But for this requirement that is larger than necessary and would also imply downstream handling of date of birth updates, which affects membership eligibility and is a separate business discussion. So it actually knows or creates a much better version, or a better suited version for the requirement we want to implement. It also has the current limitations and everything, but if we look here, make some suggestion how it should look like. And now we do exactly the implementation. Again, it has a little bit more details than the prompt, but the gist is exactly the same, which will now implement on the membership or the fitness membership side. Let's go to the code, because this is now the implementation. It uses the clean code skill to make the smallest implementation here. That is also clear. And of course, it will also add tests to do so. And when we look here, it actually has this customer email address change integration event with customer ID and email. You don't need more if you only want to update the email address. And on the consuming side, it also added the customer email address changed here as simply only this consuming. It's not a customer updated anymore. And afterwards, of course, it just stores it for the same customer ID, but it only updates the email. As you can see down here. So only the email that is updated, not the entire profile. And the second one would then also implement it on the producing side. And just basically, again, the same. This is not so interesting to watch, so I will skip through it a little bit just for you to see that it actually does also the same on that side. So it also uses the smallest possible implementation. And here it doesn't just update the entire customer, but it really also has a look at the email and only publishes if the email address has actually changed. So a little bit of idempotency. So again, you can watch the videos, of course, afterwards again, or you can prompt it yourself and you will see the difference. So we see actually here now both pass tests, both compile, but only actually one makes the decision visible. We see here the baseline actually added a customer updated integration event and added everything for the requirement, while the skill guided one just has the customer email address change integration event with the email. And a little detail here as well. The baseline simply updated here the email and published the customer updated. But of course, sometimes you don't want to receive the email address changed or the customer updated, and then in every microservice that consumes it, you have to check, yeah, did the email actually change? And if it changed, you need to maybe go through an additional workflow where you have to send out a confirmation email, for example. So in the skill guided version, actually, it will have a look if the email address has actually changed, and only then, if the email address has changed, it will publish a customer email address changed event and not else. So I will hand over to you now.
So thank you, Oliver, for this code example. So you guys can try it out on your own later. So before you start generating, ask yourself these questions first. Is our code base a good prompt? Which parts should the agent learn from? Which parts should it not copy? Are our boundaries visible enough? Do architecture decisions show up in code or only in people's heads? These questions are very important before you start generating or before you start working with AI agents. So the main takeaway from this presentation is your code is a magic prompt. And yes, in our opinion, you still need software engineering knowledge and you still need to invest in improving it. And you also still need to understand how to design software that AI can actually work with, and you as well. So if our inputs were very valuable for you or your team, you can book the free Fit for AI call, and we will discuss how we can apply these principles we presented today to your team's code base. We will send you a link later. And for our next session in about 1 month, we invited a special guest from the United States, Jamie Bogart. He's a renowned speaker and author of many libraries. He's also the inventor of vertical slice architecture, with the topic vertical slice architecture, effective guardrails for AI development. So this session will take place again over lunch break at 20th of August. So what is next? As promised, after this session, we will send you slides and recordings, the instructions, how you can book this free code-based Fit for AI call, AI agent skills you can also download directly from our website. We will send you the links and the example code base you can experiment with. Now we have a couple of questions. Yes, we do have some. Let's take a look. Okay, we have a question about skill-based AI assistance. When we want to update or extend an AI assistance capabilities, we usually need to update something like a skill MD file. From your experience, are most practical AI use cases become skill-driven, where the quality depends heavily on how well the skills are defined and maintained?
So should I mean, my opinion on that is, from what I see, I mean, we are all experimenting at the moment, right? A bit, how do we effectively use these AI skills? How do we interact with AI agents in general? And whatever we say now is like probably already obsolete again in I don't know, tomorrow. Who knows? I mean, it's really hard to tell where it is actually going. The thing about the skills is, especially the ones that we actually provide here, they're like pretty curated. So it's basically a bit expert knowledge, expert workflows, how to do something, how to assess the architecture patterns, how to write clean code, how to fix a feature envy using a refactoring, stuff like that. And these are things that you actually need to find out to some degree yourself as well. So it's not enough to take like a standardized way of implementing or of using skills, because your context might be always a little bit different. So the most important part, in our opinion, or is that the code base needs to be good enough so that the AI agent doesn't actually need too many additional inputs. So the better your code base, the better the result is going to be. If you have clear boundaries, if you have clear ways of how they interact with each other, if the code is more or less readable for a human, it will also be much more readable for the AI agent. So your judgment, if you think this is a good code base, is probably not that bad already for the AI agent. So the skill alone will probably not give you everything you need. So you cannot just say, well, now I have all my skills and I will just feed them into the agent, and then everything is going to be fine. If your code base is bad, the agent and the skill improved agent will probably not be able to make better results as before. So again, this example was pretty curated and you had really good boundaries actually, but we all know that usually everything is a little bit messy, and the boundaries are probably not that well defined, especially if you have an older system. So for that, it's much more important that you actually give the agent more context, not necessarily more skills. The skills are then, as you have seen here, like, okay, implemented, use that skill as a judgment, for example, but not as a general, well, now I have my skills and everything will work perfectly fine. You still need to have the skills to assess that your code base is good or not so good, and then decide how to actually refactor it or improve on it so that it will then be a better input for your agent. So it is the it is like that. Your code base is the prompt. Skills are just an addition. I hope that long speech now makes a bit sense.
And also as addition, in our experience with agile-like mindset helps also a lot if you don't give don't copy the text of your Jira story or ticket or however you call it and put it to the agent, please implement, but instead you think in small increment and give exact instructions. What's also very helpful is, for example, if you are talking about clean code, if you know the names of the code smells and when you mention them when you're writing your prompt. So when agent gets exact instructions what to look for.
Yeah, I think that too. I mean, the most important part probably is to follow the same process you always would to create software. Always have small things, implement smaller things, have feedback quickly, and then iterate and improve on it. So the AI agent is very good at improving when you actually are just talking to it. So this is actually also an important part of the entire development experience, in my opinion, since we are using AI agents.
We do have two other questions. Let's start with the last one first. Do you run a clean my code base run, or rephrase, how can I use the AI to help me to refactor it towards cleaner code?
So, so on in that example, actually, usually I would do something when you implement the new feature. It first of all sometimes needs to refactor beforehand to actually get the new feature into the code. And on the other hand, of course, afterwards we actually use this clean code skill exactly for that, to actually look, do we have duplications? Do we have stuff that should be extracted into into an own method, for example, and reused? And we actually do that quite often. I mean, it probably always depends a little bit on how good, again, the code quality is. So if the code is already in a good state, you probably the clean my code base run is very brief. But if you're like going to say, well, look at my entire code base and try to figure out or try to clean it up, I mean that's gonna be probably much harder. So I would always focus it on a really small part. Basically, again, how we did it before AI agents as well. Not too much, because then you open up too many possibilities for the code to break. But on the other hand, just when you change actually your code, then you also look where you can improve it. So leave your code base better than you found it, kind of way.
Yeah, exactly. Step by step, if you work on the feature, also improve the parts you touch on the way. So we do have little amount of time for very last question, and I try to summarize. It's about non-negotiables in the rules. So if we could build the deterministic guardrails which are non-negotiable, so rules or architectural tests, in your opinion, is where a way to do so?
Um, I mean, they help, of course, as they did before. Again, I think the knowledge needs to be present how to actually do it, how to design software. So if people don't know how to design software well, I mean, they also need to somehow be able to determine are these guardrails too rigid? I mean, you can make, for example, clean architecture so rigid that you cannot implement a change anymore. And on the other hand, you can make it so open that it's not really clean architecture anymore. So you need to decide also as a team what makes sense for you and also for the application, how you define those guardrails. So the thing here probably is that you cannot just standardize it. You need to make it very specific to your project.
And also team discussions are non-replaceable. You of course can add the skills, and maybe for start it's not that bad just to add skill files, but at the same time you need to discuss with your team what are our rules, what is important for us, what is not. So this part is still exactly the same like it was before. AI era, so which means you still have to learn software engineering skills so that you have the basis what to discuss and not to be too opinionated, let's say, in these discussions, but to stick to the facts. So now we are out of time. Thank you so much for showing up at this session. I hope you can take something with you. As promised, we will send all the links and everything we mentioned here. There was a question in the chat if you could add slides directly into the message. We will check. Exactly. And if we didn't have time to reply to any questions here, we will come back to it. And if you have any questions after the session, please contact us either on LinkedIn or per email. We will be happy to reply to those. And see you at our next sessions. Thank you very much.
So